the electron should radiate all its energy within seconds, milliseconds after the Big Bang, crash onto the nuclei, and all atoms should have been alienated. There should be no atoms in existence. So when they found the electron, negatively charged electron spinning around a positively charged nuclei, and it didn't slow down, actually the electron spins at near the speed of light, 99.999% the speed of light. Ain't slowing down neither. We haven't seen any of these electrons slow down. So that was a large conceptual problem when they discovered this. Well, instead of re-examining Newton's laws, they invented a new type of physics. They called it quantum physics. They said the first axiom of quantum physics is we don't care about causation. That's the first axiom of quantum physics. That means we don't care what's making this thing spin. We're going to avoid that whole problem by saying we don't care about it. And if we're asked about it, we're going to say go and see your priest or go to church or whatever. We don't answer that question. And they started from there and they said, okay, at this electron energy level, we'll call it quanta. And then we'll quantize for the next electron level and next. And they wrote the math, and so that they could predict the first electron shell, the hydrogen atom, and then they approximated all the other atoms out of it. Oh my God. Never explaining why this thing is spinning and ain't slowing down. Okay. We'll see this afternoon why, well, we'll see why this is a problem. Well, actually we'll see it now because otherwise this afternoon you won't be able to remember. But basically what happens is that look at this statement. Newton's laws are of conservation of energy. If a system does not interact with its environment in any way, that's how they all start, then certain mechanical properties of the system cannot change. They are sometimes called constant of motion. These quantities are said to be conserved, and the conservation laws which result can be considered to be the most fundamental principle of mechanics. They're called natural laws. In mechanics, examples of conserved quantities are energy, momentum, and angular momentum. These conservation laws are exact for an isolated system. All of our current physics is based on this. Nobody took the time to ask, what the heck is an isolated system? Open a physics book and look up isolated system. An isolated system implies a collection of matter which does not interact with the rest of the universe at all. And as far as we know, there are really no such system. So now you have all our natural laws based on something that is not found in nature. That is a big problem. And that is the reason why we haven't understood the electron and the atom. Because the electron and the atom and everything else in the universe all interrelate. No such thing as isolated system. There is no shield against gravity, and the electromagnetic force is infinite in range. But in order to focus on basic principles, it is useful, that's debatable, to postulate such a system to clarify the nature of physical laws. That's debatable. In particular, the conservation laws can be postulated to be exact when referring to an isolated system which was just said not to exist. That is circular thinking. Now that's where fractals come to the rescue. Because in a fractal, every system is related to all other systems. And when you write the math, when you write the physics, you're then taking in consideration all of the rest of the components that are occurring in order for that system to exist. The electron cloud and the atom is continuous because it's continuously interacting with the rest of the universe. It radiates energy, and that energy eventually curves back into it to generate gravitation, and out and in and out. And when you start to see it that way, then you can do something that's really nifty. You can look at the subatomic particle. See, the other thing quantum physics did is when they found the nuclei of the atom, now they were deep in doo-doo already, right? When they found the nuclei of the atom, they noticed that the protons were all positively charged and all stuck together in a teeny bitty thing in the middle of the atom. They calculate, you know, when you take two magnets and you try to push them towards each other, right? How they push against, right? Now they tried to calculate how much force